Hello everyone. So now we come to the last two chapters in M2. So before we start talking about this topic, we call vectors, and then you will let's revise some notations that you had learned in Form 4 first. You will see on the first page there are two very strange symbols to you, including R3 and R2. Indeed, they are talking about the set of numbers. So in Form 4, we have once mentioned about several numbers including integer. So we write here. So integer, we will use a symbol EZ with a dash here. So if we want to talk about positive integers, so then we have EZ plus. And for negative integers, we have negative integers, so we have EZ minus. So that's the notation of integer. So to concern about positive integers, you remember that we can also talk about is called natural numbers. So if you remember about it, we have mentioned once in MI, and then so it's an n with a vertical line in it. So after z and n referring to integers or natural numbers, then we have so a more bigger one, so we call real number. So you rewrite the real number again. It's like an r with a vertical line here. So then we are also talk about r plus, so referring to positive real number, and r minus for negative real number. So besides these three common notations you may see in now we have in vectors, maybe last chapter in integration, or even in MI. So there are some other notations that we may use in math as well. So they are including rational numbers, so that means it's talking about fraction. So it's a Q with a vertical line here. And then so besides we can also have complex number with C. Again, we have a vertical line between it. So after we have a very quick recall about the notation of different sets of numbers, and then next we come to have a look on the notation we have now. R2 itself stands for 2D. So because you are talking about the XY axis, and then so there are two real numbers concerning about every point. For example, it's 2, 1. And then while for R3, now you can guess it's about 3D. And then so later on we'll introduce that. So we have total 3 axes this time, referring to x axis, y axis, and z axis. And then so to every point on the plane, for example, this point will be we have 3 numbers to talk about its position. For example, it's 4, 1, and 2. So don't be scared about the symbols here, because it's the 3 and 2 itself is talking about the dimensions. It's 2 dimensions or 3 dimensions here. And then secondly, you will please also note that in printing, normally we use bold letter of R standing for real numbers. But in writing, we will be writing in this way. So it's a bit different in writing and printing. Now after revising the set of the notation of different sets of number, now we can come to talk about what is the meaning of vector. For you who are studying physics, so it won't be a very difficult thing to you, because vector itself is talking about quantity with magnitude and also direction. For example, of course, in physics, so you have your velocity, and then so we have also displacement as well. But while for non-physics students, so don't be afraid about vector, because so we are still talking about it includes 2 items called magnitude and direction. So an example that we can find in daily life, so we can talk about wind. For example, you can talk about the speed is like, let's say 12 km per hour. And then so it's not enough, because you want to know the direction. So is it blowing from the south, from the north, etc. So as a result, you need to specify the direction as well. And then so you're talking about north 20 degrees east. So this is the meaning of vector, with a magnitude and with a direction. So when you're talking about, for example, the aeroplane going from Hong Kong to Japan, so you can also talk about the direction and also the speed of the plane as well. While for compared to vector, so we have another term called scalar. Scalar itself is something we are familiar with, because it's something about magnitude only. So for example, you can talk about height. Height, there is no direction, it's just a rigid value. So for example, you are 154 cm. And then so as well as you can talk about weight. So you are like 45 kg. And then so it's talking about the scalar. Coming to math or coming to science field, vector plays a very important role, because so there are lots of things talking about direction. And then so especially when you talk about force in physics. And then in math, we are more general to talk about the idea. And then vector itself, because it carries direction, so that's why there should be 2 points we are mentioning. For example, from A to B. And then next, we need to specify the direction. Are you going from A to B or the vice versa? So as a result, we need to have an arrow saying that this is a vector from point A to point B. And here comes the notation AB vector we are introducing right now. So in your writing, so you can write in this way, AB. So specify the starting point A and the end point B. And then so the vector sign we put on top. And then so sometimes I'm lazy, you can see I just write in this way. So this is the notation of vector. But sometimes we don't want to write too much and then writing letter A, letter B. And sometimes so we can even use a letter to represent the vector. And then so in this case, we will use small letter to distinguish the difference between capital letters referring to points, while vector we are talking about small letter. But A itself is not enough to talk about vector, so that's why we have a notation here as well. And then so A vector now representing a vector from A to B. So now we talk about the arrow, and then how about the length, because we need to know the magnitude as well. So here comes another notation which we have it before, and then so it's like an absolute sign. And so we have different idea about it, because in vector, so this is called magnitude, or the value, magnitude. So magnitude of A vector, how long is it? But in the past, we have 2 other ideas or 2 other definitions. So do you remember what are they? So the first case is when we are talking about numbers. So this is called absolute value. So absolute value. So for example, like absolute of minus 7 is 7. Absolute 4 is still 4, for example. And then the other situation, can you remember it? Hopefully you can still remember. So it's the other situation we use the symbol is indeterminate. Wow, that's something quite a long time ago. So you still remember how to find it? For example, like this one. Or even 3 by 3 determinant. For example, 1, 2, 3, 4, 5, 5, 6, 7, 8, 9. So for my convenience, I just do the first one. And then so the direction of calculation would be this direction positive, this direction negative. And then so that's why it's 4 times 1 and minus 2 times 3. So alas, it goes to minus 2. For the second one, so of course I won't do it to you, it's too big somehow to me right now. Afterward, then we talk about the equal. So what do you mean by equal? The length vectors are equal. Now you will see, so there are examples in the next figure. So including a vector AB, including a vector CD. Now if you read them carefully, you will see that both of them share 2 equal things. So one is, so you see they are same direction because they are pointing, or you can say it's a parallelogram. Besides, you see that they have also share the same magnitude or same length. So in this case, we call the vectors, they are the same magnitude. We call the vectors are the same. So as a result, you will see the other 2 pairs, for example, boy dog and also AC. So they are equal in length, equal in direction, and we say the vectors are the same. Of course, you can talk about opposite direction like BA vector, DC vector. So we can also say they are equal to each other. So after introducing the meaning of vectors, notation, and also the meaning of equal vectors, then we have some special vectors to introduce as follow. So first of all, it's a very funny thing. Vector can be 0, of course, but we don't write 0 because 0 is a value, but we use 0 vector to represent it. So what do we mean by 0 vector? So here is an example. From A to A, you do nothing, and you stay at the same point, and then we call it is a 0 vector. After 0 vector, then we have another term called unit vector. So it is hard to understand at this moment because we need later on we will put vector together with the study in coordinates. So for example in 2D, and then so we have xy axis when we study about equation of straight line, parabola, circle, etc. And then but coming to vector, you will see that every point can be reached by horizontal movement and a vertical movement. So it's like step by step reaching, for example, is 4, 3 at this point. And then so that's why we need to define a term called unit vector so that I can reach 4, 3 from the point 0. And then so hopefully it's a common sense to you. That means I need to walk 4 steps to the right and walk up 3 steps to reach the point. And then so as a result, we need a term called unit vector to define it. So horizontal movement, and then we call it is a I vector, while vertical movement is called J vector. So that's why later on we will introduce that if you want to talk about 4, 3 vector, 4, 3 for this point. So in vector notation, it means that it is 4 I vector. That means move to the right by 4, and then so you go up for 3 units. So that means it's 3J vector. So for details, we'll talk about it later. But anyway, you have an idea about the unit vector first. So afterwards, then we have a term called negative vector. So it mainly talking about the vector is moving in an opposite direction. So like AB vector and minus BA vector. And then so if they are walking back, then so the vector will be different by a negative sign. And then later on we'll check, we'll see more examples about it. So next, the class exercise called 13.1 as follows. It's a very simple exercise for checking your understanding in vector very quickly. So how about you pause for a minute and try to do the 4 questions as follows. Okay, so let's see whether you can obtain the answer properly. And then so first of all, you have AB vector. So how about we draw in this way, AB vector. So in order to find a vector which is equal to it, and then so that's why you search for one which is parallel to it. So you have ED, and then it should be in the same direction. So that's why the answer will be ED vector. While for the second one is EF, so let's change the color here. And EF, so I put it in yellow. EF, so you need to specify direction as well. So in searching for another parallel vector, so it's located at BC, but the direction should be from C to B. So that's why the vector will be CB vector. And then similarly, we have FA vector, so I put in green, matching to DC vector. Sorry, because the question is about, I overlooked the question, it's negative vector. So that's why FA vector, so would be negative of CD vector, because it's in opposite direction. And finally, we have BC vector. So that's why in opposite direction, so we have BC vector equal to negative of EF vector. So of course you can play trick because besides FA vector, you can also talk about minus AF vector. So you're just using FA itself but in opposite direction. And so as BC vector, you can write as negative of CB vector. So both of them, they are called negative vectors of its original one. After defining some ideas about the vectors, now we come to the operations of the vectors. That means we should be considering how to add them, how to subtract them, multiply, or is it possible to have division? So let's start from the easiest one, talk about addition of vectors. So there's a law called triangular law or parallelogram law. So what is it? So when we are talking about AB vector plus BC vector, so it can be read as in this way. AB vector, that means from A to B. BC vector is like B to C. So that's why at last the outcome, so I put in green, that means you're from A at the first and end at C at the end. So that's why the outcome will be AC vector. So that's why you can just read from the letter, you will see from A to B, so B, then B to C. So that's why it comes up with AC vector. So of course, if we use notation A vector, B vector, so then it's simpler because there is no capital letters over there, and then so it's okay. A vector plus B vector, of course, is A vector plus B vector. But you will see the direction will be different. And so A vector, B vector, originally they're separate. And then, but a plus b vector, it refers to another vector in another, what should we say, direction. And then the other case will be called parallelogram law, but I would be treated the question in this way. So for example, now you're talking about AB vector plus called AD vector. And then so that means you are moving from A to B at first. But next, you are supposed to move from B to somewhere. So that's why you need to have a like of transformation or transition, because this AD vector can be moved to BC vector. So that's why you can think it as AB vector plus BC vector afterward. So in this situation, you will see that it's more easier. It's easier to understand that our outcome would be AC vector afterward by using the idea like from A you move to B, then reach C. So that's why the outcome is AC vector. Next one would be the most harder one about to most of the students, because we are now considering the magnitude of vector as well. To have a better presentation, how about I add one more information? Besides AP is called A vector, so I want to add that so magnitude of A vector is equal to 3. So now we are going to draw the 4 vectors as follow to see what actually they mean. So for example, of course we don't know what is the meaning of 3 units. Is it like 3 cm or 3 something, 3 inches, etc. So to make it simple, so I just casually draw A vector first in this way. So 2A vector itself, that means it's a double of the A vector. So when you draw, so you approximately draw a double vector of double length, and then we call it is called 2A vector. So see if it's okay. And then coming next, you see the next one is called minus A vector. So what does that mean? Is talking about negative direction, and then but negative A itself should share the same magnitude or same length. So that's why minus A vector would be drawn in this way. So opposite direction of the blue one, while the length is still the same. The last one, what I said is the hardest, is called 1 over magnitude of A times A vector. So you have to look at the symbol very carefully. Now, first of all, 1 over magnitude of A, this one is a constant. So it's just a number. In particular, because now I told you that magnitude of A is 3, so that's why this one you can treat it as 1 over 3. Dot is times. So that means the idea of this vector indeed is talking about 1 over 3 of A vector. So now you can see A, I cut it into 3 pieces, approximating equal length. So that's why the yellow one representing this new vector called 1 over magnitude of A vector, and then times A vector. So if we are given the length of 3, then hopefully it's easier to understand what's the meaning of 1 over magnitude of A vector. But if this one, the number is not given, then it comes to a bit trouble later on when you read or to do a question about vector. So finally, and then so there are some rules of vector. So most of them, they are kind of common sense to you, like vector addition can be swapped. Vector addition order can be changed, like we add B plus C first or A plus B first, it doesn't matter. A plus 0, so it's still A vector, because 0 vector means moving, the point doesn't move. And then so in vector notation, we always like to use lambda and mu. Okay, let's wait. So there are 2 Greek letters. This one is lambda, and then so this one is called mu. And then so these are 2 constants, Greek letter constants we like to use in vector form. And then so multiply constants is, so the order will be okay. So for example, like number 4, you can treat it as like 2 times 3A vector. So you can treat it as 3 times, not 3. We should be write it as 2 times 3 A vector. So because either one of them will be 6A vector finally. And then number 5, so it's like expansion. Number 6, expansion as well. And then the hardest one would be talk about number 7. So because we are talking about vectors are equal. And then so they are composed of A vector and B vector respectively, A vector, B vector respectively. So like comparing like terms or comparing like terms. So that's why later on you can say lambda 1 is lambda 2 and then mu1 is mu2. So there's an example to illustrate the idea afterward.